back to the JakeJoshTeam channel, and today we're going to be focusing on Mercator Sailing. Let's get right into it then, shall we? Alright, so on your coastal exam, one of the questions is going to be a Mercator problem. And a Mercator problem will read as such. A vessel at longitude 11 degrees 22 minutes south, longitude 009 degrees 18 minutes east, heads for a destination at latitude 06 degrees 52 minutes north and longitude 57 degrees 23 minutes west. Determine the true course and distance by Mercator Sailing. So when you start a Mercator Sailing problem, you're going to want to make a note of where you're coming from and where you're going. The resources you're going to need for a Mercator Sailing problem is just going to be your Bowditch Volume 2. In particular, you're going to go to Chapter 10, the Sailings, to get your formulas. Okay, so Bowditch Volume 2 is going to be provided for you on your licensing exam. What you're going to need to know, though, is you're going to need to know where to go in the book for formulas for certain problems like these. So in Bowditch Volume 2, you're going to go to Chapter 10. Chapter 10 is the Sailings. All your formulas for Great Circle Sailing, Mercator Sailing, Parallel Sailing, that's all going to be in Bowditch Volume 2, Chapter 10. Then you're going to want to skim through Chapter 10 to find Mercator Sailing. Now, Mercator Sailing, the formulas for it are located in section 10.07. So, you skim through the book, you find Mercator Sailing, and you find the formulas. When you get to section 10.07 of Chapter 10, the Sailings, in Bowditch Volume 2, you're going to see that the formula for Mercator Sailing is tangent C, C is true course, equals the difference in longitude, I publish it as capital D dot LO, the difference of longitude over meridional parts. I'll say that again. Tangent C equals difference of longitude over meridional parts. Where do you get meridional parts? Well, you essentially get them from your latitude, and you go to Table 5 of Bowditch Volume 2. And as we go on, you'll see how we get there. But first, you got to understand this is the formula you're going to use to find your true course and to find your distance that we're sailing. Distance equals difference of latitude. I put a cursive L to represent difference of latitude times secant true course. So it's essential that we're going to have to solve for one of these to figure out the other one. But going back, distance equals the difference of latitude times secant C. If you go back to your trigonometry class, you'll remember that 1 over sine is cosecant, 1 over cosine is secant, and 1 over tan is cotangent. So an easier way to write distance for Mercator Sailing, you can write the distance sailed, Mercator Sailing, equals the change of latitude divided by the cosine of the true course. So if you want to pause the video and just write down what each of these means, go ahead and do so, just so you can keep track of everything that we're going through. So now that we have our formulas written down, we know what they all stand for, all the acronyms, what they all stand for. We know where we're coming from and we know where we're going. We can begin to solve for our change in latitude. Now, a note I want to make before we actually begin solving the difference is when you're sailing from a north latitude to a south latitude or vice versa, you're going to add your two latitudes together. When you're sailing from a north latitude to a north latitude or a south latitude to another south latitude, you're going to subtract. So, with that note in mind, we're going to take where we're going from and where we're going to. So I put latitude 1, where we're from, was 11 degrees, 22 minutes south. And latitude 2, where we're going to, is 06 degrees, 52 minutes north. So after that, draw a little chart of the Earth. We're coming from position 1 and we're going to position 2. So we're going up, we're going north. So make a little note that this is north sailing. Since we know we're going from south to north, we add these two latitudes together. So when you add latitude 1 and 2 together, you'll get a difference of latitude of 18 degrees and 14 minutes north, because we're north sailing. Then the next thing you gotta do, since we're doing Mercator Sailing, we have to change our degrees of our difference of latitude into minutes. And we know that 1 degree equals 60 minutes. So what you're gonna have to do is you're gonna have to multiply 18 degrees by 60 and then add on the 14 minutes. So 18 degrees times 60 gets you 1080. Then you have to add on the 14 minutes, because originally it was 18 degrees, 14 minutes. And 1080 plus 14 gets you 194 minutes north. Once you solve for that, make a little note on the side, and then continue on solving for the difference of longitude. Now the next step, we're going to find our difference of longitude. So we know our longitude 1 was 009 degrees, 18 minutes east, and longitude 2 was 057 degrees, 23 minutes east. So like I said, I always like to draw the little Earth, and then I plot where I am. Starting out, I'm in the eastern longitude, and I'm heading to a western longitude. So we have to go 9 degrees to get to Greenwich, and then we have to go another 57 to get to our destination. So therefore, we have to add these longitudes together to find our difference of longitude. So we know we're adding, so when we add our longitudes together, we get 66 degrees and 41 minutes west. Remember, this is a Mercator Sailing problem, so we're going to be solving these formulas in minutes. So 1 degree is 60 minutes, so we need to times 66 by 60, which gets us 3,960. Then we have to tack on the 41 minutes, so 3,960 plus 41 is going to get us 4,001 minutes. And remember, we were west sailing, so 4,001 minutes west. Get that down and put your difference of longitude on a note in the corner. Okay, so we found our difference in latitude, we found our difference in longitude. Great, we're almost there. Now remember, this is a Mercator Sailing problem. We also have to find our difference in our meridional parts. Essentially, we have to find the difference of latitude, but what they convert to in meridional parts. And I'll explain that as we go. Is you're going to want to find what 11 degrees and 22 minutes converts to in our meridional parts. So to do that, we go to Table 5 in Bowditch Volume 2. And I will put a picture on the screen, but you just flip through. Now the tables are in numerical order in Bowditch Volume 2. So Table 5, it's near the beginning of the book. So what you do, and I'll put a picture up on the screen, is you open up the book and you keep flipping through Table 5 until you get to the page where you have the latitude. The latitudes are at the top of the page. You flip open to the page until you find the latitude that matches your degrees of the latitude you're trying to convert. So after you find the latitude you convert, the numbers that are going down the page on the far left of Table 5 are the minutes. So we have our degrees, which sit at the top, and we have our minutes that are at the very left of the page, but they go downward, and those are the minutes. And what you're going to do is you're just going to slide your finger from 11 degrees, the degrees you want, all the way down until it matches up with the minutes. And on the page, you can see that 11 degrees and 22 minutes gets you 682.0 meridian parts. And all you're going to do is you're just going to mark that as your M1. Alright, so now that we found M1, let's go ahead and find M2, latitude 2, and convert it to meridian parts. Again, I'll put a picture on the screen. And remember, you're going to go for the degrees, which we find on table 5. Meridian parts, we find 6 degrees. And now we're going to scroll down to 52 minutes. So 6 degree column, all the way down to 52 minutes is going to get us 410.2. So you find that, and then you make a little note. And in the next step, we have to find the difference between these meridian parts. Alright, so we found M1 and we found M2. Now what we have to do is we have to do the exact same thing that we did for latitude. We got one meridian part from the south and one meridian part distance from the north. So since they're different latitudes, we add them together. If they were the same latitudes, they were both north, we would subtract them. If they were both south, we would subtract them. But one's south and one's north, so we add these parts together. When you add your meridian parts, you get 1092.2. And that is your M. So take your M, make a note, and now you have all the pieces to the puzzle to solve your formulas. Okay, so we have our pieces to the puzzle. Let's start plugging and chugging. So, we'll start with finding true course. So the tangent of true course equals our difference in longitude, 4,001 minutes, divided by our meridian parts, 1,092.2. 4,001 divided by 1,092.2 is going to equal 3.66325. After that, you're going to need to use your calculator. And it's going to have some trigonometrical functions on it. So, we need to find the true course. So with your calculator, you're going to have to get C by itself. So you got to make tangent inverse. So to find true course, you take tangent inverse 3.66325, and when you calculate that out, you should get 74.7 degrees. Now that we found the inverse of our tangent, and we found that true course is 74.7 degrees, we have to account for what kind of sailings we were doing. North, south, west, east. Well, we know we were going up, so that's why we put that north on our latitude. So you circle north, and we knew we were going from east to west. We were doing a western sailing on our longitude, so you circle west. So our true course really is north 74.7 degrees west. Now we have to figure out what that is, what direction we're really going on the true course. So you can put, of course, true. Okay, so now we need to find what our degrees are actually on the true course. So we know we're sailing north and we're sailing west. So we're sailing, our direction of sail is anywhere from 270 to 000 degrees. Continuing on this diagram, if you were southwest, you would take whatever course you found and you would add it to 180. If you were southeast, whatever course you found, go 180 and subtract that course from 180. And if you were northeast, it's just 0, 0, 0, and you add your course. So for us, we were northwest. So we're going to take our course and subtract it from 0, 0, 0. Well, 0, 0, 0 also can be translated as 360. So we take our north 747 degrees west, and we're going to subtract it from 360. And that is going to get you 285.3 degrees true. And that makes sense, because we're sailing north and we're sailing west. So we're sailing this way. So our true course is 285.3 degrees true. That's part one of the question. The second part asks us what was our distance. So now we're going to take not our true course, but the course we solved for on a tangent to find our distance. So now for part two of the plug and chug. So we know that our distance equals our change in latitude divided by our cosine of our course that we solved for. Our course was 4.7 degrees, but true course was 285.3 degrees. But when you solve for Mercator Sailing, you're going to use the course with the directions. So our distance equals 1094 divided by cosine 74.7 degrees. Punch that into your trigonometric calculator and you will get 4,152.3 nautical miles. And that is the distance we sailed on a course of 285.3 degrees true on Mercator Sailing. So when all said and done, your answer is 285 degrees true, 4,152.3 nautical miles. And that is how you solve a Mercator Sailing problem.